Hello everyone, very warm welcome once again in AIATS plus phase 2 discussion program. And yes, you all know that this is the program where we just solve plenty of the question, we understand the concept and proceed for the NEET preparation, right? This is something which gives us the confidence that how to solve question, how to understand that what type of questions being asked in the NEET examination, and in the short duration of the time with the time management how we would solve these questions, right? So I hope the students who have participated in this program are getting the benefit of it. Very good morning, people started joining. This is nice to see all of you from the previous session, now in this session, and further more sessions are also there. So stay tuned here. And what about me? I am your chemistry faculty. I'm Nidhi Panwar, and I'll be taking some of the portion from the chemistry part. So what are the topics? Those we will cover today. First of all, I'm taking the first chapter, that is some basic concepts of chemistry. Gomti, so Gomti is saying hi to Mukesh, but what I am saying that hello to everyone. Very good morning everyone. Yeah, so the topics those I'm taking here, structure of atom it is, BCC the first chapter, then periodic classification, chemical bonding and the chemical kinetics. So these are the chapters or the topics more specifically, those we are going to take from here. Okay, so Asim, very good morning. Shall I start now? MS. So MS Dhoni, hi everyone, good morning. And the turn is for the discussion of mock test 7 from this important program, personalized learning for ultimate success, and the success is NEET examination, to participate there and to get the good rank, to get the dream medical college, right? Okay, organic chemistry please. So organic chemistry will also come, don't worry Gomti. MS, not Gomti. Gomti, good morning beta. So MS, don't worry, organic chemistry is also would be there soon. After this session, there would be the session on organic chemistry, more specifically GOC, hydrocarbon, that you will also find, and same ways the chapters from the class 12, haloalkane arene, aldehyde ketones, right, and alcohol phenol ether along with amine. So don't worry, everything is here in this discussion. So entire day, the chemistry team is with you. You will be getting the sum of the portion. Even from the inorganic section, you will be getting topics here. Okay. So very good morning. Suman, Dashrath, Art Center, Hani and Anamika, everyone, Ishani, good morning. And the turn comes to start the session. I hope everybody has joined, and those who haven't joined yet, don't worry, join here and simultaneously ask your queries if you have any. I'll be solving. Fine. So first of all, let me just see why my switcher is not working. Let me see. Yes. So I've taken the pen as well. Okay. So the question is question number 46 from the paper mock test number 7, and the question is from some basic concepts of chemistry, mole concept. Yes beta, yes. Gomti, I've just started. Hi, good morning Arsh. So the number of moles of methane required to produce 22 gram of carbon dioxide after complete combustion. So the question is from the reaction stoichiometry, and Hilal 0.5 mole, 222. Okay. So let's see how to solve this question. Though it is very easy, and yes, if you are preparing for the NEET 2025, this is a kind of question which is just like eating pudding, right? Okay. So methane, you have CH4 reacting with oxygen, because burning it is complete combustion, sufficient amount of oxygen you are providing. Asim said option 2. Okay, I'll be looking at this. So complete combustion of the hydrocarbon results in the formation of carbon dioxide and water. Along with that, energy is being released, right? And what happens here? We need to balance this equation as well. I did the same. Now you can, yes, easiest question, right? But there is no scope of making mistake in such question. +4, definitely you should get if you know that. So here, while analyzing the reaction stoichiometry, what I observed that 1 mole of methane, 2 mole of oxygen, 1 mole of CO2 and 2 mole of water. This is overall proportion, right? If you are taking this way. Now suppose the amount of oxygen is not sufficient, that may be the limiting reagent, or this amount of methane that you are providing, you have to just identify whether something is limiting reagent or not. So in this question they are not talking about oxygen, because the question is about complete combustion. It means oxygen is in sufficient amount. So the amount of the product formed would be dependent on the amount of methane taken. And in this question, if it's been asked that what is the limiting reagent, then definitely methane it would be, undoubtedly, because complete combustion it is, oxygen is sufficient, right? So this will decide the amount of the product formed, whether it is CO2 or H2O. Am I right? Okay. So now the number of moles of methane required to produce 22 gram of CO2. So very easy question, 22 gram of CO2 you have. How many moles of CO2 it would be? Mass upon molar mass, right? So these are the moles of methane available, which are provided in the question, right? And how many moles of methane are required? As per the reaction stoichiometry, 1 mole is needed for the production of 1 mole. So by just comparing this by the simple unitary method, we have two relation between CH4 and CO2. Yes, exactly. Because the given substance, given reagent that you need to look at is methane and the product is CO2. We need to compare this only. So 1 mole is producing 1 mole. So 0.5 mole of methane will be producing 0.5 mole of what? CO2. Done. So simple to opt for the option 0.5 mole, and all of you who have just marked there that option 2, Asim, MS, Arsh, Hilal, everybody is right. The names, those I am able to read right now. Okay, so don't think if you have already written and I have not taken your name, don't worry. I know that you have solved this. Okay, so 0.5 mole. Now just let me know that suppose the question asks you that what is the volume of the CO2 formed? Tell me the volume of CO2 formed. Write on the comment. Write in the comment so that I wouldn't be knowing. What's the volume of CO2 in this case? The simple mole concept you need to apply. I hope you know that if 1 mole of the substance you are taking at STP, a gas if you are taking, then 1 mole of that gas has the volume that is 22.4 liter, am I right? Then what would be the volume of the methane formed? Just let me know. Here how much amount of CO2 is being produced? 0.5 mole is produced, right? 1 mole means 22.4 liter. Then 0.5 mole means half of it, right? Half of it. So if you are making half of it, then 11.2 liter of CO2 would be produced in terms of volume, right? Okay. Now in the similar question, they can ask you to find out the number of atoms of oxygen present in CO2. So yes, 11.2 liter at STP. Very good, Gomti, Asim, very good. Okay, so number of atoms of oxygen produced in the form of CO2. If it's been the question, then what you will be doing? You know 0.5 mole of CO2 is produced. Then how many molecules of CO2 it would be? 1 mole means any number of molecules, right? Half mole means 0.5 Na of the CO2 molecules, right? Isn't it? Right? Now the question was how many moles of oxygen are there in the obtained CO2? How many atoms of CO2? What I asked, right? So if I'm just looking at this 0.5 Na, suppose 1 molecule of CO2 is being produced, then 2 atoms of oxygen it is present there, 0.5 into Na, right beta? These are the molecules, Asim. Now oxygen atoms are double of it, right? Because 1 molecule of CO2 means 2 atoms of oxygen. So this is how you can proceed in such type of question. If some question is asked this way, That also you can solve by just looking at the given amounts and the formula of the compound, right? CO2 is being obtained. One molecule of CO2 has 2 atoms of oxygen. Now you have 0.5 Na molecules. Molecules of CO2 actually. This is the amount of that CO2 molecule produced. Good morning, Shaheen. Good morning. No, not that late, not that late. We have only discussed this question. And if you are the participant of AIATS Plus program, you know that the simple question where CO2, how much CO2 is produced after complete combustion of 0.5 mole of methane, right? This was the question, 0.5 mole because 22 gram of methane you are taking. One thing, we just misread this. Okay, just give me a moment. The question is about the number of moles of methane required. So, opposite if you proceed, then also the same question, right? Now, 0.5 mole of CO2 you want to produce, so 0.5 mole of methane is needed, right? This way we need to take it. And further, what I was asking Sahin here, that in this question, one molecule of CO2 if you are just taking, then 2 atoms of oxygen are present and 0.5 Na of CO2 molecules you have here, then how many oxygen atoms are present there? Definitely you need to multiply. This way. Done? So, Na atoms of oxygen which are present in CO2. So, simple thing is just look at the given amount of the substance, compare it with the obtained amount, right? So, as in this question, they just gave you the amount of CO2 produced and they were asking that how much methane is required, right? So, don't misinterpret. The question is the number of moles of methane required to produce CO2, right? 22 gram of CO2. And as per the question, if you proceed this way, that 1 mole of CO2 is needing 1 mole of CH4, right? And you have 22 gram of CO2. It means 22 by 44 we have already taken. Yes. This way 0.5 mole of CO2 available, it means this is the amount of CO2 you are considering. Then how much methane is needed? So 0.5 mole of methane is needed, right? Now, what I asked that this way you can find out the number of molecules as well and also the number of atoms present in the species. Hope it is clear, right? Hope it is clear. Shall I move forward? Shall I move forward further? Okay. Now, the next question is the question number 47 and that question says the total number of the significant figures in 3.04520. This is a number which is given. I hope you know about significant figures. How to find out? Yes, Hilal said 2. Okay. So, significant figure, the first thing, just check all non-zero digits. Those all are significant in a number. All non-zero digits, right? Further, zeros between 2 non-zero digits, right? And what? And the preceding zeros, the zeros after a number, right? But the condition is those zeros should be after decimal point, right? So, zeros at the end provided after decimal, right? And the fourth rule is all the counting numbers have infinite number of significant figure. So this you need to remember. So I just wrote here entirely that just count all non-zero digits, zeros between 2 non-zero digits, right? Zeros at the end which are provided after decimal point. This is condition, right? And further, counting numbers. Counting numbers have infinite number of significant figure. Right now the question that we have is very simple, that you have 3.04520, right? So this 0 is also significant because it is after a decimal point. Further, this 0 is significant because it is between the two non-zero numbers, non-zero digits, right? Just count option 2. Option 2 or 3. Just check. Just check. Sukanya is writing option 3. Hilal, Arsh, Sahin. I just ask you, just cross check once again. 0 would be significant if it is present after the decimal point, beta. Okay. So it should be 1, 2, 3, 4, 5, 6. Third option is correct, bache. Third option. Asim? Yes. MS said 5. Not 5, beta. You have to check once again. That last 0 is after the decimal point, right? That's why. Okay, though this is a simple question or the concept which is in the very beginning of your syllabus, but if this type of question, because in the previous and NEET examination, the question based on significant figure is being asked, right? So you have to revise once again. Okay, so writing mistake. Oh, got it. No worries, Hilal. Yes. So now the turn comes for question number 48. Okay, what question number 47 says? Which of the following represents the correct relation for Heisenberg uncertainty principle? So I hope you have studied the dual behavior of matter, right? And when I'm talking about the wave nature of the subatomic particle, there are the two concepts which we look at. The first is the de Broglie or the de Broglie principle. What it is? What it says? That subatomic particles have both wave-like nature as well as the particle-like nature, right? And how these natures are related? That lambda, if you are just taking, that lambda is inversely proportional to the momentum of the particle, right? And that constant which comes here is h. That value of h is, just let me know the value of h, Planck constant, h by mv. This we are taking, right? H by p or h by mv. P is the momentum and momentum is mv, right? This is de Broglie principle. The second is absolutely uncertainty principle, Heisenberg uncertainty principle, and that's been asked here in the question itself. What is that? That you cannot identify both position and the momentum of a subatomic particle with the accurate precision. If you are analyzing one, then definitely there would be large uncertainty in the second one, right? So expression for the same is delta x into delta p is greater than or equal to h by 4 pi, right? Yes, the value of h is very good, Asim, very good. 6.626 into 10 raised to the power minus 34 joule second, right? Now, here just look at delta x, delta p. So it can also be simplified to m delta v because mass is the constant thing, right? You cannot change it. So it's greater than or equal to h by 4 pi. So what I can do? I can just send this constant mass from here to here as well, right? So if you know the position of the subatomic particle with certainty, then there would be the large uncertainty in the determination of its velocity, right? So this is uncertainty principle provided by Heisenberg, and when I'm looking at the question given here, which of the following represents a correct relation for Heisenberg uncertainty principle, just have a look. Give the explanation. Heisenberg uncertainty principle. Okay, Tanmay. So, Tanmay, what actually it represents, that Heisenberg principle, if we talk about, I'm not able to look at your comment. Your comment is missing now. Anyways, So Heisenberg uncertainty principle, if we talk about, what it says that if you have a subatomic particle, it is not significant for macroscopic objects, right? Macroscopic particles, if you just look at, then in that case mass would be such a huge, and same way the de Broglie principle is also not applied there, because the mass would be so large that wavelength of the particle would not be analyzed as per the de Broglie principle. And same ways for the uncertainty principle provided by Heisenberg, there also if you just look at the uncertainty in the position and the momentum, if I am just looking at both of these, then it is greater than or equal to h by 4 pi. So this is the mathematical expression which represent the Heisenberg uncertainty principle, right? And now what type of question you would ask? Like this is the simple question where they have just given you the two terms, you multiplied, and this relation is there. So it's easy to do, but what they can do, they can give you the question or the numerical question based on this concept or this equation, simple to say, okay? They can just provide you the certain uncertainty. Suppose they can provide you the uncertainty, they have just given you the velocity, certain velocity, say 100 meter per second, the velocity is given, and the uncertainty is given as 2%. Then what would be delta V? 2% of this, right? Uncertainty is more in product of delta X and delta P. So, yes, this is momentum beta. So, this we need to take, na? Yes, formula based question can also be there, right? Uncertainty is more in product of X and P. So delta X and delta P if you are taking, and if there is large uncertainty, suppose you just have the particular trajectory for the movement of electron, then it means you have determined the position, and if you have determined the position, then definitely there would be the large uncertainty in its momentum. Tanmay, are you getting this point? Okay. So here, this is the uncertainty in momentum and this is uncertainty in its position, right? No, that type of question could be asked. Sahin, you are asking that X is equal to P. Uncertainty in position and uncertainty in momentum is equal. Then how would you analyze the uncertainty in velocity? So in that case, you can just equate these two terms, and instead of delta X, you can keep here delta. Instead of delta X, you can keep there delta V beta. Okay, Sahin? Getting it? Now, so what I was asking here, that suppose 100 meter per second is the velocity given and its uncertainty is 2%, then what would be delta V beta? This would be 100 into 2 by 100, right? So it would be, uncertainty is 2 meter per second, that you will be taking. Delta V would be 2 here, right? So this way you can proceed. You can find out the uncertainty in position as well by just applying the formula. Okay, and as Sahin said that can there be such type of relation that delta X and delta P are equal, then in place of delta X you can keep here delta P square, right Sahin? This we can do. Suppose in the question it is given that delta X is equal to delta P. It means uncertainty in momentum and uncertainty in position both are equal. In that case, in place of delta X I just kept delta P. And that would be equal to, I can just equate it with h by 4 pi this way, right? Now what else we can do? We can just write here that m delta V, because delta P means m delta V, mass will not be changing, so it's constant, that is equal to root of h by 4 pi, this we can take, okay? And from here, because m is constant, so we can send m there also. So delta V is equal to root of h by 4 pi, and here 1 by m can come. And rather writing m here, if I just keep this m inside the root, that way also expression can be given, or it could be written as root h by 4 pi m square. So this way also they can represent, or they can keep this 4 and m both out of this root. So in that case, it could be written as h by root h by pi, and this 2 M will come out of the sphere. So this way also they can express. So variation in the expression they can give you by just giving you the simple value. So what value we observed here? That in this case, what we assume that delta x and delta p are equal. Then what is the relation between, the value of the delta v, how can calculate it? So it can be calculated by simple using this formula or this formula. These are the similar things. Done? Okay? हिंदी में समझाइए. ओके, सो हिंदी में क्या है, यहाँ पे आपने अनसर्टेनिटी इन पोजिशन एंड मोमेंटम की बात किया है बेटा. सो डेल्टा एक्स एंड डेल्टा पी, द प्रोडक्ट ऑफ दीज टू इज ग्रेटर देन और इक्वल टू 4 पाई. टर्मिनोलॉजी तो सेम ही रहेगा ना. ओके, सो व्हाट हैपेंस इन दिस केस, अनसर्टेनिटी इन पोजिशन एंड अनसर्टेनिटी इन मोमेंटम को अगर आपने इक्वेट किया जैसा कि मैंने यहाँ पे किया, देन अनसर्टेनिटी इन वेलोसिटी कुड बी कैलकुलेटेड दिस वे. इसको आप कैलकुलेट कर सकते हो. कैसे? बिकॉज आपने डेल्टा एक्स की जगह पे डेल्टा पी ही रख दिया है एंड इसका स्क्वायर हो जाएगा, बिकॉज डेल्टा एक्स इंटू डेल्टा पी था वहां पे, आपने यहाँ पे डेल्टा पी को ही रख दिया डेल्टा एक्स की जगह पे, तो स्क्वायर हो गया. देन फर्दर रूट किया आपने एंड ये एक्सप्रेशंस आपने निकाले हैं. ठीक है. एंड इन दिस क्वेश्चन आपको करेक्ट रिलेशन बताना था, हाइजेनबर्ग अनसर्टेनिटी प्रिंसिपल, दैट यू ऑप्टेड फॉर. द राइट आंसर इज ऑप्शन 1. आई होप एवरीबडी इज क्लियर अबाउट इट. Is it clear for all? Just write there in the comments so that I would be knowing it. Everyone, is it clear? And continuation with the next question. I hope it is clear. Okay? Because I'm not getting your comments. Either these are delayed. I didn't find any comment. Now, question number 49. Okay? Once again, the very simple question. Diagonal relationship is shown by. Okay, good. Diagonal relationship. So, if you have studied the periodic table, then you know that what this diagonal relationship is. In the periodic table, if you just look at the group, period 2 and 3, and beryllium and aluminium. Yes, it is given here. Okay, Vaishnavi, Sukanya, and Insan. Okay, so first term I am not using. Okay, so diagonal relationship you will find among the elements of period 2 and 3, and lithium is showing the diagonal relationship with magnesium, right? The similar charge to radius ratio. That is the reason similar type of chemical property you will also observe, right? And along with that, this is in the group 1 and this is in group 2, magnesium. The same way, in the group 2, beryllium is there, and beryllium is showing diagonal relationship with the element of group 13, that is aluminium, right? And yes, definitely beryllium and aluminium are showing the diagonal relationship. So everybody just please note that though the chapter periodic classification doesn't seem so difficult, it's like this is very, very easy, but still the important concepts are present there. So I just suggest you all just have a reading of this chapter, get the important concepts from there, because you need to apply them, and definitely question would be there in the NEET examination, right? So now the turn comes for the next question, the question number 50. So here this question says the hybridization state of the central atom in SF6. Sulfur, that's a hexafluoride of it, right? Ma'am, chemical property same होता है दोनों के. Yes, आपको similarity मिलेगी, exact same तो नहीं, but हाँ similarity in the property you will identify. Okay, आपको similarity मिलेगा इंसान. जैसे हम लिथियम मैग्नीशियम की भी बात करें, so लिथियम एंड मैग्नीशियम दोनों एटमॉस्फेयर में रिएक्ट करते हैं ऑक्सीजन के साथ साथ, नाइट्रोजन से भी, नाइट्राइड भी बनाते हैं. Okay, now once again for this question, the hybridization state of the central atom in sulfur. How to find out hybridization? By just looking at the steric number, and that is just add the present sigma bonds, whatever present there in the species, plus lone pair. Okay, this is how we proceed. And in case of SF6, sulfur is bonded with the 6 fluorine atoms, right? So sigma bonds 6, there's no lone pair, and 6 is the steric number, so hybridization would be definitely 1 s orbital would be there, and the maximum 3 sp3p 3p orbitals, and the remaining d orbitals. So sp3 d2, right? And this is the hybridization. What would be the shape of it? What's the shape of this SF6? Which shape it is? Just write down. SF6. The two fluorine atoms are here. Is it octahedral? Is it so? sp3d2. Yes, Vaishnavi. Samrat. Octahedral. Great. Great. Very good. Very good, Atharva. Arsh. Ansan. Sukanya. Study Empire. Great. Very good. So, sp3d2. Tell me the name of the compound where sp3d3 hybridization you identify. Yes. sp3, a compound with sp3d3 hybridization where the steric number is 7. Any example? I'll give you the hint. A compound of xenon. A compound of xenon. The hybridization sp3d3 it can be, it can have. IF7, that's good, Arsh. And a compound of xenon as well. IF7, very good, very good. What about XeF6? XeF6, right, Atharva, right. IF7 as well, because 7 sigma bonds with iodine, right? Interhalogen compound, IF7. If you have studied the P block in the inorganic chemistry, IF7, not 6, I'm sorry, IF7. Yes, sp3d3. And if I'm just saying XeF6, not XeOF2 beta, XeF6. In this case, there are 6 sigma bonds and 1 lone pair, right, Atharva? Now correct. Atharva, you are right. IF7, XeF6. Okay. So here 6 sigma bonds plus 1 lone pair. So steric number 7, sp3d3 is the hybridization, right? So just keep practicing because question based on hybridization is the favorite with respect to NTA paper preparators. They just use hybridization because this is the important concept as well. Okay. Now I'm taking the next question, the question number 58. Have a look on it. What is the slope? The question from the Chemical Kinetics. Okay. And it's a good question, and with the help of the graph and even the Arrhenius expression, Arrhenius equation, you can go with this question. So temperature, if you are raising for a particular reaction, then it's been observed, experimentally it's been observed that its rate get usually doubled or tripled sometimes, right? Generally it gets doubled, okay? Now, just to relate rate constant with the temperature, an expression is being provided by Arrhenius. EA by RT. What EA is? What is EA? That is activation energy. This is how we relate. And if you just take log, because in the question they just asked that log K versus 1 by T. So if you are taking the natural log, then how do we represent? We represent ln K, that is equal to ln A minus EA by RT. This is a natural log. And if you are taking this log on the base of 10, then log K is equals to log A. Natural log is sometimes represented by log E something, right? So log K, log A this way minus EA by 2.303 RT, right? Now what you are doing, you are plotting log K versus 1 by T. It means log K you are taking at the y-axis. I am taking the equation of the straight line y is equals to mx plus c. Right? Mx plus c. And c is the intercept that's been represented by log A. A is the Arrhenius constant, everybody is aware. And on the x-axis you are taking 1 by T. This is at x-axis. So the remaining thing is representing m, which is slope, and this negative sign is representing that slope is the negative slope or the downward slope, right? So what type of graph you will be getting? So here 1 by T you are taking at x-axis and log K you are taking at the y-axis. Then you will be getting a graph this way, and the slope of this graph is what? It is minus, just check, have a look once again. See, EA by 2.303 R, right? So, this is the slope. And what about intercept? This is log A, intercept. Done? So, suppose in place of slope, they just ask you that what is the intercept of the graph, that would be log A. Now, the right answer in the question is option 3, and all of you are absolutely right that you are marking the option 3 as the right answer. Done? Shall I move forward? Shall I move forward? Just write there in the chat section as well. So, this type of question could be there. Further, they can even ask you to find out the activation energy by using this Arrhenius equation as well. Log K is equals to log A minus EA by 2.303 RT, and for the two different K values, they can give you log K2 by K1, that is equal to EA upon 2.303 R, and bracket T2 minus T1 by T1 T2. So, that formula can also be used. That's also the derivation from the Arrhenius equation, right? So, that question is also the part of the 12th syllabus, and that can be there in your NEET examination. So, keep revising and try to solve more and more questions, okay? Now, further, next question that I am taking, though the question is too easy, where's the question? Yes, it is here. Question number 68. So, what it says, number of electrons, neutrons and protons. So, this can be said that it's the easiest question, right? Because in this question, you have a species, and what that species is? Uranium. Isotope of uranium you have 23592. This is atomic number, and it gives us the number of protons, right? And if it is the atom, not for ions, for atom, this is equal to number of electron as well, right? Okay. And what about the number of neutron? Number of neutron is equals to mass number 235 minus 92. How much it would be? See, P and E 92, and this is not 235, this is 238. 235 is another isotope. So, in the question it is 238 given, na? So, 238 you have to take. Now, do it. Option 3, is it? Okay. 8 minus 2, 6. Then 4, 1, 146. Yes. So, neutron, undoubtedly option 3. Further, they can ask you, yes, it's 238, right, beta? Two different, yes, sign. With respect to the previous question, the question of Arrhenius equation, on different temperature EA could be asked to find out, or the ratio of the K to K1 could be asked. So, that was the Arrhenius equation, that's very important, okay? Now, the simple question, but yes, easy questions are also there in the NEET examination. So, this can be the one of them. Okay. So, answer is 92, 92, proton and electron, because this is the sequence, electron and the proton, and in between neutron. So, 146. Done. They can even ask you the isoneutronic species, the species where the number of neutrons are same. That could be asked. Isotopes, isobar, related to that also questions being asked. Okay. Now, next question from the question number 69 it is, and it's from chemical bonding and the molecular structure. Question says maximum covalent character is shown by, right? You have the different species given here, and beryllium chloride, magnesium chloride, sodium chloride, rubidium chloride. So, beryllium chloride is from the chloride of the group 2 element beryllium, magnesium chloride, the chloride of once again magnesium from the group 2 we are taking. First one, okay. Then NaCl and rubidium chloride. I hope everybody is aware that what Fajan rule is. The three important things it talk about, right? First thing, that so far smaller cation, larger anion, Fajan rule. Very good insan. So, Fajan rule says that if you are considering the ionic compound, that also has some of the covalent character, the one thing, right? And how to identify that if you are considering the ionic compound where the cation and anion both are present, then if the cation is small, right, and anion is large, as Insan wrote there, larger anion, or the more charge on cation. This is also one of the condition. More charge on the cation, right? Or species or the cation, I should say, with pseudo noble gas configuration. One example is also given there. Pseudo noble gas configuration. In all such conditions, there would be the larger covalent character, right? Polarization directly proportional to the number of charge. Yes. So there is the capacity of cation and anion, the polarizing power of cation and polarizability of anion, that we need to look at. So if cation has the small size and the more charge, then its polarizing power is more. That lead to more covalent character. And the similar way, if you have the larger anion, that anion would have higher polarizability, and that leads to higher covalent character. And in this question, they just ask you about the maximum covalent character, right? So now if I'm just looking at the ions, this is Be2 plus ion, because anions are same, so there's no need to compare an ion, only cation needs to be compared. Mg2 plus, Na plus, and rubidium, the largest cation here. So it would have the highest ionic character, rubidium chloride, because the largest cation it is with the least charge. Okay? While if I'm talking about magnesium and beryllium, both have the 2 positive charges, but the size of beryllium is smaller. In the group 2, if you just look at, you find that beryllium, then magnesium will come. And the size of beryllium ion is smaller. Okay? That is why its polarizing power is more. And due to that, it would lead to the higher covalent character. So as the question is maximum covalent character, definitely first is the answer. But suppose the question is about the highest ionic character, then what would be the answer? In that case, the answer can be changed to rubidium chloride, because rubidium ion would have the largest size. Is it clear? Right, everyone? Samajh aaya? Sabko? Yes. Okay. Now, एक example that we need to take about the pseudo noble gas configuration, the one. Yes, insan. Okay. So pseudo noble gas configuration. Suppose you have CuCl and NaCl. Both have chloride and ion is same in both the cases. Right? Absolutely, Rehana. Rehana and insan mark there. Fourth, if the question is about ionic character, the highest ionic character. Okay. Now, you have CuCl and NaCl, right? Now, in case of Na, the cation is Na positive, and here also, there is not the large difference in the size as well. Then in that case, which would have, okay, Samrat. So, Samrat, I'm just explaining about, in the previous one, what it was, that Fajan rule says, if the cation is small, because the same anion we are considering, and it has more charge, then more covalent character would be there. Okay. So in this question, the only thing that we considered is the size and the charge, the two things. And with respect to the size, the smallest is beryllium. Along with that, it has the charge also higher side. That's why it has the maximum covalent character. Right. Now, if I'm talking about the last point that I've wrote, pseudo noble gas configuration, what it is. So if I'm talking about CuCl and NaCl, Cl is same, the anion is same, the only different thing is cation, and both the cations have the unipositive charge, 1 plus charge there as well. Size is not that different, but the question is which would have the more covalent character than the species with the pseudo noble gas configuration. What is the configuration for Cu+? Copper has the exceptional electronic configuration 3D10-4s1, isn't it? Right? And if you are saying Cu+, it means this becomes 0. Now, 3D10, or simple to say that N-1 D10 and NS 0. Right? It shows that this has the completely filled subshell, the completely filled valence shell, and it's a pseudo noble gas configuration. Right, Samrat. So this is pseudo noble gas configuration. While if I'm talking about Na plus, so very simple, Na plus is 2p6 3s1 for Na, and for Na plus it would be 2p6 not N 3s0. Okay, so this is NS0 . My pen is working in a weird manner. This way. This is noble gas configuration, or simple to say neon like configuration. Yes, neon का configuration achieve कर लेगा. Okay, so इस case में Cu plus is showing the pseudo noble gas configuration. That's why higher covalent character it would have. Okay, and higher ionic character is aligned with sodium chloride. So this is what is Fajan rule. Clear? Okay. So now I'm taking the next question. From there, the question number 80, simple question, but from this table chart, we can get, okay. So, what this is saying that you have the certain properties given here and you are matching it with the list 2. If you know the quantum number, if you have studied the chapter 2 clearly, then you can easily solve this. The question is about the number of orbitals in a subshell. I have to change the color of my pen because it is not visible here. Number of the orbitals in the subshell, number of subshells in a shell, maximum number of electrons in a shell and maximum number of electrons in a subshell. ये आपको याद होना चाहिए, right? You have to always remember it because in this question they have given you to match it, only the formula matching. But they can simply ask you to find out that number of electron as well by just giving you the certain quantum number. Then also it would be helpful. Okay. So Vaishnavi wrote here the option 4 is the right answer. Okay. Let's see. Number of orbitals in a subshell, number of subshell in a shell. So first of all, what I'll be matching here, that maximum number of electrons in a shell are given by the principal quantum number, that is 2n square. Right? C is matching with the fourth one. What I am doing here, C is matching with the fourth one. Now further, maximum number of electrons in a on the subshell I will be coming later. Number of subshell in a shell. So this is given by the principal quantum number. So with respect to shell, the two things I have matched. Number of subshell in a shell, n. Suppose I am talking about the second shell. So there would be two subshell, one s and one p subshell. Right? Not orbital. There is a difference between subshell and orbital. I hope you know. In the s subshell, there is only one s orbital. In the p subshell, there are 3 p orbitals, right? px, py, pz. Okay? So this is how we work. Now, number of orbitals in a shell. So in a shell, the number of orbitals are 2l plus 1. That L is the azimuthal quantum number. Okay? So that azimuthal quantum number, I hope you know that if L value is 0, 1, 2, 3, S, P, D, F. Right? So if you know the L value, you can find out the number of subshell in a, the number of orbitals in a subshell, and simultaneously you can also find out the number of electrons in a subshell. How to find out the number of electron in a subshell? 2L plus 1, number of electrons in a shell. I have to change the color once again. Visibility is an issue in this case. Yes. So 2L plus 1, this is just representing the number of orbital in a subshell. Just multiply 2 to it. So it would be 4L plus 2. Right? And 4L plus 2 is visible there. Here. This is 4L plus 2. So it needs to be matched here. Done. All the matches are here, and this is very good thing about you all, that you know that what's the answer for this question, and undoubtedly option 4 is the answer. A2 here, then B1, C4 and D3. Correct answer, correct match it is. Clear? Okay, everyone, is it clear? And if it is clear, then I have to take another question. Okay, the next question is based on hydrogen bonding. Okay, from the chapter 4, once again the question you have, and it says the magnitude of the hydrogen bonding of a compound is maximum in its solid state, right? So, ma'am वो NCERT का ग्राफ समझा दीजिए, ऑर्बिटल वेव फंक्शन और नोड वाला. Okay, Zan. So, first I'll be taking this question. Okay, general configuration of F block, please. I'm coming to that. So, the magnitude of the hydrogen bonding of a compound is maximum in its solid state. So, hydrogen bonding, if hydrogen is bonded with some electronegative element, suppose fluorine, then there is the charge separation, right? So, partial negative charge, partial positive charge it would have. Okay. So, further another molecule would be bonded with it because of the electrostatic weak forces, not electrostatic, these are. Because of this polarization, there is the formation of a weak bond which is called hydrogen bond, right? Now, in the solid state, intermolecular interactions are more, right? And because of that, in solid state, the extent of hydrogen bonding is more, okay? So, now, the magnitude of the hydrogen bonding of a compound is maximum in the solid state is true. Now, when I am talking about the pH3, so first statement is correct. The second statement says pH3, this is phosphine gas, right? It does not show hydrogen bonding. If it was showing hydrogen bonding, then phosphine, just like ammonia, can be a liquid, but it's not. Because in case of phosphorus, the electronegativity is not that much, okay? And that is why, because electronegativity is not that much, then in that case, this is a phosphine molecule that we take. Electronegativity difference is not very much. So, charge separation is not there and there is not the formation of the hydrogen bond, okay? And if hydrogen bond is not there, so the statement is right. I need to mark, oh, so sorry, right here, okay? Done? Shah says third is the right answer. So, both the statement correct, then definitely third is the right answer, okay? Right? Now, one more question that I need to, not hydrogen bonding. Yes, Sahin. Okay. The next question, for a reaction which is going on, R is given as, the question from the chemical kinetics, K, rather writing once again, let's have a look because time is also moving forward. One reaction is given, its rate is equal to K, it's directly proportional to the concentration of CH3COCH3, propanol we have, raised to the power 3 by 2. So, concentration of propanol raised to the power 3 by 2 and concentration of oxygen raised to the power 1 by 2, right? So, how to find out the order of this reaction? Which order reaction it is? The power in the rate expression, just sum them up. So, with respect to ketone, it is 3 by 2, the order. With respect to oxygen, it is 1 by 2, that's also order. And overall order is 3 by 2 plus 1 by 2, that is 4 by 2 or the second order. This is second order reaction, right? And the question is about the unit of the reaction, rate of reaction. Rate of reaction is dependent on the concentration of the reactant with respect to time, this you are taking, and the unit for the concentration you take is mole per liter, and for the time it is second, so it would be second inverse. So, this is the unit for the R, generally we take, okay. Now, when it comes to the unit of the rate constant, so unit of K if you are calculating, if you are finding, so take the concentration you are taking, raised to the power 1 by n, n is the order and time inverse. This is how you calculate, and as the concentration we measure in mole per liter, this is the second order reaction. So, we have to just mark here 1 minus 2 and time is in seconds. So, second inverse it would be, how much it would be? 1 minus 2 is minus 1 and mole inverse it would be mole inverse, then liter second inverse, this way, right? And yes, it is there in which option? Just check. Mole inverse, liter second inverse, and mole per liter per second. So the second option is the right answer, beta. Not the first one. Third, how? This is mole liter second, not third one. Not third one. Okay? Sign, just have a look once again. This is mole liter second, not mole per liter per second. This should be. Okay? Right, everyone? So these many questions we discussed, and yes, this is the time to take your leave, because there is another session which is aligned for you all, right? And as you said initially that organic chemistry, then definitely organic chemistry you also find. Okay? Sahin, Shaz, and whatever the doubts I just found in the chat, I'll try in the next session to clarify all those doubts if anything left. Okay? No worry, Sahin, it happens. But it's important practice now, so that there would be the negligible chances of the mistake in your final examination. Right, everyone? So time to take your leave. Thank you so much for having patience, right? And please keep practicing more and more. All the very best. Thank you so much.